Okay, so here we've got three general examples of acid plus alkali reactions. We've got three different acids with three different alkalis, and we have hydrogen chloride, hydrochloric acid, hydrogen nitrate, which is nitric acid, and hydrogen sulfate, which is sulfuric acid, down at the bottom there. And what we can see is that in each of these cases, we have a hydrogen, i.e. what we've already discussed, is how we define an acid. It's something which donates a hydrogen ion. But we can see that in each of the cases, there is the presence of a hydrogen with the presence of a hydroxide. And this is the case in each of these four examples, and is the case in a large majority of acid and typically alkali reactions. And we have this common similarity. And if we look at the equations that we have, we know that one of the products that we form is hydrogen hydroxide. And it's fairly obvious then what has kind of occurred here. We've had hydrogen hydroxide form. Now, hydrogen hydroxide is the fancy name for water. And the hydrogen hydroxide has formed in a reaction between those two parts of the acid and alkali. This has then left us with a byproduct, spectator ions, as they are in the fully written equations, but we have left ourselves with a byproduct, or what we would call in an acid-alkali, acid-base reaction, as a salt. Okay, and what we're doing in this is we are preparing a salt of an acid-alkali reaction, and it is the formation of the salt depending upon the names of the acids, not whether or not we have an acid or not. It is the type of acid that we have reacting with the type of alkali that we also have. So you can see in the first example, the salt that we will produce is sodium chloride. The salt we will produce in the second one is lithium nitrate. And in the final example, we would see that we would form magnesium sulfate. This hasn't changed the fact that we have undergone a neutralization reaction. We have still taken an acid and we have reacted it with an alkali. We've taken the hydrogen part and we've reacted it with the hydroxide part. This has given us the formation of water. For GCSE, what we've done is ultimately an acid of reaction, a reaction equation here, and we've taken a hydrogen ion and we've reacted it with a hydroxide to produce water, so-called neutralization reaction. Okay, but for lower down school, where we're looking at the word equations primarily, what we're looking at is the formation of the salt, and the formation of the salt is dependent upon the type of acid that we use. If we used hydrochloric acid, we would produce a chloride. If we reacted nitric acid, we would produce a nitrate. If we'd use sulfuric acid, we produce a sulfate. We always produce water. Water is always produced, hydrogen hydroxide. That's always produced. So it allows us to get a very generic overall reaction of an acid plus an alkali, or base sometimes, to produce a salt plus water. And the type of salt produced depends upon the type of acid. Like we say, whether a chloride, nitrate, sulfate, phosphate, ethanoate, or anything like that, reacting with the type of alkali, sodium hydroxide, lithium hydroxide, magnesium hydroxide, etc., calcium hydroxide, etc., etc. So by using the words, we can then use that to predict the type of salt we will produce, and also, in every example, the presence of water.